Greetings and welcome to my new calculus channel. I'm John Gabriel and this is the new calculus channel, and today we're going to be discussing book 5 of Euclid's Elements, definition 9 and 10. So let's begin. Now definition 9 and 10 are very important definitions, but if you look at how Heath translated them, he doesn't really make very much out of it, and he gets this last part of the 10th definition wrong, and I'll get to that in a moment. But let's go through these definitions one by one, and then we'll see what they mean, and we'll come back to the rest later. So definition 9 says that if you have three magnitudes, as you see here, P, Q, and R, and they're in this proportion, P to Q is as Q is to R. Okay, so P is to Q as Q is to R. And if you have that, then this implies that P is to R as P squared is to P cubed. As P squared is to Q squared. I'm sorry, and I've written down the values here. Now notice, there are many similar triangles here, okay? And only this configuration here without the second line here. So this red line to this blue line is in proportion to this blue line to this green line, okay? And it doesn't matter how you do that, they'll always be in proportion, okay? As long as this is in proportion to this and this is in proportion to this. So there are many other similar triangles for which this identity does not hold, okay? So look at all these other similar triangles, and you'll ask, well, why am I using similar triangles like this? Well, if you go to book 6, you'll see that in book 6 you'll have a lot to do with similar triangles, and it covers those very same concepts that you find back in book 5. And that's why I've always claimed that book 6 should have come before book 5. And you'll see, of course, even in proposition 12 of book 6, that you have a similar argument with, in this case, with the line segments and the constructions. So I think it's much easier to look at book 6 first and then book 5, because that way you'd be able to understand them better. So this is true regardless of how you position these 2 points here, okay? So the way to do this is to just choose any 2 points you like, right? And then draw a line through those 2 points, and then of course just have this proportional to this as P is proportional to this. Okay, so all of book 5 is much easier to understand, and book 5 is a difficult to understand book if you first study book 6. The only thing that you need to know before you study book 6 is what is a ratio, and that's not very hard. Okay, so that's definition 9, and definition 10 says that when you have 4 magnitudes like you have here, then the first is to the second, is to the fourth, the cubed ratio as it has to the second. So what we're looking at here now is in definition 10. Well, first of all, definition 9 tells us that there exist similar triangles, but not all the similar triangles have that property. And then definition 10 tells us that Heath mistranslated this last definition here, because the Greek says os analogia υπάρχη. So that means if the proportion exists. Okay, so definitely won't happen in the case of a triangle, because a triangle only has 3 sides and you have 4 sides here. So you're looking at a higher dimension geometric object. Can't be a rectangle, because a rectangle has 2 pairs of equal sides. So Heath mistranslated the definition, because the Greek states that the statement is true only if such magnitudes exist. Well, why would such a stated ratio not exist? Let's see. First of all, a ratio whose aliquot parts cannot be measured by the same magnitude is a ratio that has no relationship between its aliquot parts, right? And then secondly, not all ratios taken in such a proportion will satisfy the definition. So Definition 10 cannot be stated in terms of similar triangles, only in more complex geometric objects. So in the next video that will follow this one, sometime in the future, we'll cover more of the definitions. We're almost finished with Book 5 definitions, but they're very important because Book 5 is the most important book in Euclid's Elements. So once we've finished, now we've only got about another 7 or 8 definitions left to cover. And then we can start on the propositions. And the reason I'm going slowly on Book 5 is that it's such an important book to cover. And of course, I know I haven't covered Book 4, but I'll go back to it also again at some future time. My name is John Gabriel, and this is New Calculus Channel. Till next time, folks, goodbye.